Hello and welcome. Please pause the video, read the problem, and try it on your own. Okay, so we're told here that Connor wants to attend a town carnival. And the price of admission is $4.50, so write that down. So the admission cost equals $4.50. So to get into the carnival, you have to pay this amount. And then each ride costs an additional 79 cents. So I'll write that in dollars. So rides equal $0.79, right, or 79 cents. And then if he can spend at most $16, so the maximum amount of spending that he can actually take part in here is $16, right? So he has $16 to spend at the carnival. Which inequality can be used to solve for R and find the number of rides he can go on? Well, think about this, right? One way to structure this equation is just to say Connor has $4.50, right? He has to spend One way to think about this is that we're trying to find the maximum number of rides, R, he can go on. So we're trying to find the total cost of the One way to think about this is that we're modeling his cost as long as the cost of everything he spends is less than or equal to 16. In other words, we can model this situation by saying that he can spend this much, $4.50 plus $0.79 per ride. And that cost, whatever that is, the $4.50 to get in, and the number of rides he can go on at 79 cents per ride, or $0.79 per ride, must be less than or equal to $16. So that helps us eliminate choices 1 and 2, because in choices 1 and 2, if you look at them, those two questions set it up so that to get into the carnival it's 79 cents or 0.79 cents, and then it's $4.50 per ride. Now we want to figure out the number of rides that he can go on, so we solve for R. I'm going to take $4.50 from both sides, and that means we have 0.79R is less than or equal to 16 minus $4.50, which is $11.50. And then to solve for R, we divide both sides by 0.79. So R is less than or equal to 1150. Oops, got this, second quick. 1150 divided by 0.79. 14.5. So R is less than or equal to 14.5. Let's see if that was 5569. So about 14.5. In other words, since you can't go on a half of a ride, I guess we're assuming you can't, the number of rides that Connor can go on before he goes over his budget is less than or equal to 14.5, and that means 14. You can go on 14 rides, which is choice 3. If this isn't working for you, another way of solving this problem is to just break it down as you would. You might not set up an equation, and this is really the same thing as an equation, just written in a different way. You would say, okay, we have $16, and it costs $4.50 to get in to the carnival. So that means I have $11.50 left over. Then I would take $11.50, the total amount of money I have left, and divide it by the cost of a ride. And that would get me about 14.5. And if you look at this, this is saying, okay, I can go on 14 and a half rides or 14 rides. This logical way of stating it, probably the more common way of solving it, is mirrored exactly in the equations here. If you look at these equations, right, follow the steps. Took 16 and subtracted 450. That's exactly what we did right here. Then that was 1150. We divided by 0.79. That's what we did right here. These two, right, ways of setting the problem up are identical. The advantage maybe to this second part is that what you're figuring out first is the number of rides, and then you're figuring out which equation represents the answer you know is true. In other words, if you knew he can only go on 14 rides, you know the answer would have to be choice 3, which is the only one that has 14 rides as an option. All right, thanks.